Math 2 Unit 5 review. I am at home and my children are with me, and so it could be getting a little crazy here. I hope that I'm not loud and obnoxious. This has been known to do weird things to my voice. I think if the computer times out, I start sounding like a robot. And I think in just a minute here, my 4-year-old Elsie wants to show you a picture. So please be patient with me. I want to get you this review tonight. I'm sorry I didn't get it in last night. I got busy, ran out of time, and I'm taking my personal family time to make one. And it's not going to cover every problem like it usually does. Thank you. But hopefully it covers a little bit. Now this is not the actual review. I downloaded it, but it didn't download right. So let's just try a couple of them. Number 4, and I've never popped back and forth. Mary, it's okay. Just leave it. I've never popped back and forth from my screen to another document. I have this pulled up on my computer so I can see what the functions are. Okay, the very first thing I do, I mean, you can do this a lot of different ways. If I want to find the x-intercepts, I have to factor this. This has to be in factored form. Mary, be careful. You're going to ruin my chairs. This has to be in factored form, and the very first thing you do to put it in factored form is pull out of GCF. So I notice that there is a -2 that will go into each of those terms. So when I pull out the -2, I'm left with x squared plus 2x minus 1. And then if I want to play the game with that, you ignore the -2. I'm looking for two numbers that will multiply to a -1 and add to 2. -1? Nope, +1. It's a +1 because when I pull out the -2, I'm left with plus. Oh, you want to show a picture of our family? Okay. You get to show 2 things. Is that one of the things you want to show? Sorry. Again, you're grateful I'm taking time out of my personal life, right? Okay, let's show that.
Not me.
Well, put it underneath the screen. Sorry, pause. This is a picture of last 2 Christmases ago, when I only had 2 children. I think the 3rd was on the way. Hurry, sweetheart. Mommy has to do this. You make sure. Oh, there we go. So, there we go. Right? So cute. And Elsie, do you remember how old you were 2 years ago? Were you 4? No. Were you 3? No. Were you 2? Yep, you were 2. You can say yes.
Yeah.
Now say hi, class.
Hi, Ash.
Pull out your sucker. Try again. Say hi.
Hi, Ash.
Hi, class. Say, are you studying your math?
Is adding new bath?
Say, you better do good.
Better do on.
Say, stay in school.
And I.
Get good grades.
And ways.
Okay, if you tell me that this happened on the test, you'll get extra credit. Oh, and there's her sucker. Oh, okay. Yeah, you're hilarious. Okay, no more. Give Mom a second. Okay, so let's go back to the problem. Now, if I want to put that in factored form, Elsie, do it again. Do it again, and you're going to get in trouble, okay? If I want to put that in go watch Super Y. If I want to put that in factored form, I need to have it multiply to 1 and add to 2. Well, there's only one thing that multiplies to 1, and that's 1. -2. So there is only one x-intercept because these are the same thing. Marion, don't touch the computer. The x-intercept happens at -1, 0 because it's the opposite of the +1. But because there's 2 of them, I'm going to...
Okay, stop. Because there's 2 of them, I'm going to say it has a multiplicity of 2. Stop. You'll get down. Multiplicity 2. Now the y-intercept is 0c. You have to have this memorized. Y-intercept 0c. So I'm going to take that -2 right there and say 0 minus 2. 0c. Now the axis of symmetry happens right in between the 2 intercepts. But when the intercepts happen in the same location, if I were to sketch this, my intercept is right here. That is the axis of symmetry when both of the intercepts happen in the same place. So the axis of symmetry is x equals -1. The domain range we will talk about next time. The vertex we've already said is right here. -1, 0. Otherwise, if you couldn't do this, if it wasn't landing in the same spot, hi baby, if it wasn't landing in the same spot, we would use the -b/2a for that, right? X equals, make sure it says x equals. And then for the vertex, we would plug it in, right? To find y. But in this case, it's on the axis. All right, now, how do I know if it's a maximum or a minimum? Well, you need to know if it opens up or if it opens down. So looking at this equation, the -2 indicates that the graph should be opening this way. So the graph is opening down, which means this point right here is a maximum. And the maximum value is the highest y value, which in this case is at 0. Increasing, decreasing depends 100% on the line of symmetry. This is the line -1. On this infinity, I have positive infinity. On this side, I have negative infinity. And now we look at the graph. If it was a roller coaster, on this half the graph, I would be going up, right? So this is the increasing section. And then this is like the butterfly moment where the graph turns. And then you start going down. This is the decreasing section. So it is increasing from -infinity to -1. It is decreasing from -1 to infinity. Okay, moving on. Number 5, given each graph, I don't know which one I did in what class. Most of my classes, I think we did number 5, so let's do number 6. Given this graph, oh, Marion, is that yummy? Yeah. Why don't you sit on your bum bum? Sit down. Good girl. Uh-oh. I'll find it. Sit down on your bum bum. Okay. There you go, sweetheart. Sorry, this is the perk of being a working mother. So on each of these problems, it tells you above, it's gone, you have to find the vertex, the axis of symmetry, the x-intercept, the y-intercept, the max-min value, and increasing and decreasing. So there's lots of answers on this one as well. The vertex is the turning point, so it's happening right here, -1, 3. On the test, I would start with this problem. The test looks kind of like the review, where the first page there's just a bunch of garbage you have to write down. I would still sketch the picture. I think that there's value in that. Get down there. Are you getting down? I think there's value in that, of sketching the picture, but I still maybe would start with number 6 or something like this, so that you have an idea of what's going on when the picture is provided, and I hope that it makes problem 1 and 2 easier. The axis of symmetry is the line that cuts the graph in half. This line right here is -1. I'm going to write it up here, -1. So the line x equals -1 is my axis of symmetry. The x-intercepts, now these ones you have to estimate. 1/2 is right here. I don't know, maybe 0.7. So the x-intercepts happen at 0.70 and -2.70. I don't know, something like that. It's an estimate. The y-intercepts happen where it crosses the y-axis, so I'm talking 0, 2. It is a maximum, and the highest value, or you're talking y value here, is at 3. And now we do the intervals where it's increasing, decreasing. So I have my negative infinity out here, my positive infinity out here. If you are on the roller coaster, in this interval, my graph is going up. So this is my increasing interval. Then it turns, and now the graph is going down. So this is my decreasing interval. A slight personal note, I've never explained that so good, so I hope people understand and you get that right on the test. I feel like this is the year that maybe people understand. I like breaking it up like this, where you have your 3 numbers. Those are the 3 numbers that go inside of your intervals. And then I like looking at it like it were a roller coaster. This is where my graph's going up. And then it tells you, like, this is the interval for increasing. So it is increasing from negative infinity to negative 1. It is decreasing from negative 1 to infinity. Number 7, what characteristics, I think I did that in all my classes, but what characteristics of a parabola can be identified when in standard form? Standard form looks like this. Easily I can tell the y-intercept. And the y-intercept again is 0c. Now this 0c part's not part of the answer, but just a reminder, when you have to do that on the test tomorrow, that's what you'll do. Alright, number 8, what characteristics, I think the numbering got all screwed up. What characteristics of the parabola can be identified when the factoring form of a quadratic is given? Well, factored form looks like this. Ooh, x minus p, x minus q. So from factored form, you can easily find the x-intercepts. There is a form that we haven't talked about yet that you'll be able to easily find the vertex. That's my favorite one to talk about, but we will do that next unit. And hopefully you'll feel like that's a piece of cake. Well, next unit meaning after Christmas. Hopefully you feel like that's a piece of cake because you know most everything that you'll need to for that. Maybe. No, okay, not everything, but the graphing part at least. I don't know what I'm talking about. Anyway, moving on. Number 8, describe how to find the x-intercepts in factored form. Well, if I give you factored form, which is this one right here, the x-intercepts are p0 and q0. You take whatever number is in there, change the sign, that is p, so those are the intercepts. If it's in standard form, though, the first thing you have to do is factor it. If it doesn't factor, you use the quadratic formula. If it does factor, then you find the p and the q the same way you did above. Alright, number 15, a function is a maximum value at 22 and the x-intercepts of negative 6 and 8. What is the value of x that maximizes the function? So, I'm saying, hey Marin, I'm saying I have an x-intercept here and an x-intercept here, and somewhere I have some maximum value. I wonder what x value. Hi. Oh, I know. Oh, you look homeless. I'm wondering what x value. Oh, I know. You're fine. What x value will give me that maximum? Well, isn't that the vertex? The vertex gives me the maximum, right? So what x value hits the vertex? This is negative 6. Mare and Amelia. This is negative 6. This is positive 8. So in order to find the, it's a little bit harder. You don't have the boxes. The easiest thing to do is average them. Do not hit my computer, please. The x value of 1, thank you, baby, will be the vertex. Okay, go play. Whee! Oh! Good girl. All right, next page. What is it? What is it? All right, let's look at number 8.
Is number 8 the one that has multiple choice? Let me look. La, 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 la. Where is it? Oh, number 18? I don't know. I'm all sorts of confused. I was pretty sure that one of them had multiple choice, so I don't know. I think this got changed a little bit. I honestly have no idea. So let's look at number 18. I don't know if this is your number 18. Can you find it? Where am I? I left school, realized I said I would make this video, and then I didn't bring a copy of it home. So now I'm just confused. If I want to write the equation that goes through those zeros and passes through this point, excuse me. Excuse me. I'm first starting by, I have to put it in factored form. Well, that's the equation for factored form. Now these are my zeros, and this is my extra point xy. So I could substitute all 4 of those into this equation and solve for a, because we can plug almost everything in at first, just giving the zeros. So we take the opposite of p, plug it in here. Take the opposite of q, plug it in there. We do the opposite because of the little minus sign right here. Then we are all done except for we need to find a. So we need to temporarily substitute these values in so that we can solve for a. So I've got 7 equals a times, everywhere there's an x we put a 2, 2 plus 3. Everywhere there's an x we put a 2, 2 minus 5. That's the same thing as saying 7 equals a times 5 times negative 3. 7 equals a times the negative 15. Divide the negative 15. Oh, that's not the final answer, so don't circle it. Now we're going to take that a equals negative 7/15 and plug it back into the original equation right here. Final answer, y equals negative 7/15. Kind of ugly. You can get that to a decimal, but once you change it to a decimal, you're approximating it. And it no longer is an exact answer. So you have to be careful. Okay, number 20, I think looks something like this, I hope. In order to find the discriminant, and then state the number and type of solution. So this right here, I hope, is a reminder of what the discriminant is. If you stop at this word, and you're like, I don't remember what discriminant means, you've sold yourself short, because you knew what it meant before I even told you the word was discriminant. If I want to know what number and what kind of solutions there are, it all depends on the square root, right? The quadratic formula looks like this. Oh, you can't even see that, sorry. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's what the quadratic formula looks like. Now the number and type of solutions is dependent on the number inside of the radical. Now before you can find a, b, or c, you have to make sure that it's set equal to 0. Guaranteed tomorrow on the test there's going to be a problem that's not set equal to 0. So before we even start, let's subtract the 6. 2k squared plus k plus 9 equals 0. And then let's plug it into here. A equals 2, b equals 1, c equals 9. So 1 squared minus 4 times a times c. The 4 is part of the formula. I could explain why, or you could trust me. I actually couldn't explain y to you right now, simply because we haven't learned y yet. But maybe one day I can, if you are very interested. Alright, so that's, let's see, 1 minus 70.
72. So that's a negative 71. My discriminant is a negative 71. Because it's negative, it's imaginary. Because it's not a whole number or not a perfect square, it is irrational. Oh, and there are two. Sneak that in there. Two imaginary irrational solutions. The number is 2, the type imaginary irrational. So we did that today in class. Let's do another one. I'm going to jump over to 21, which I believe should say this. This is almost in standard form. There really is a plus 0 here. So A equals negative 5, B equals negative 9, C equals 0. So plugging this in, B squared minus 4 times A times C should give you 81. Yeah, that just goes away. 81 is a positive number, so I'm going to say that that is real. 2, real. Rational. Now, why did I say rational? I said rational because it's a perfect square. If it was a 36 or a 49, 100, that's the number 2. Man, I'm losing my voice. Sorry. I guess teaching for 8 hours and then videoing for another hour does something to you. I'm sorry. All right, 23. Let's graph a couple of these. Here's how I would do it. If it's in standard form, I could try to factor it. It probably will work. I just want to practice both ways. Let's start by finding the line of symmetry, because everything's based off the line of symmetry. So negative B over 2A would give you 8 over a negative 2, which would give you negative 4. So it's right here. Now somewhere along this line is the vertex. To find the vertex, you plug in negative 4 to all of your x values. And I did not bring a calculator home with me, so I'll just kind of do it off the bottom. You get 4. So your vertex is at negative 4, positive 4. Careful, Mary. The baby's back. Say hi. Say hi. Say cheese. Here, let's move the binky. Say cheese. So cute. All right. So that means your vertex is right here. Now, oops, sorry. What's so cute? Hold on, Mare. Sorry, pause. I wish I could pause this and take care of my family for just a second. If I pause it, it stops the recording. And I just want to do it all in one shot. Hi, Marion. Do you want to sit on the swirly chair? You want to go sit right here in your spot? It's so hard to teach math and have a 1-year-old in your lap. Okay, so now we have to remember what the general pattern is for a quadratic. Normally, we would go over 1, up 1, over 2, thank you, up 4, right? But because it's a negative 1, or the A is negative right here, right there, I'm going to take all of my ups and I'm going to take all of my ups and I'm going to multiply it by a negative 1. Thank you. So rather than going over 1, up 1, I'm going to go over 1, down 1 on both sides. And rather than going over 1, up 4, I'm going to go over 1, down 4. And you, Marin, stop. And you keep putting points on until, thank you, no, Marin, no.
Sorry, she just like gouged me with a marker. So you keep, no, Mare.
And the band.
Okay, you keep putting points on until your graph can't hold any more points. And there it be. What do you want for dinner? So let's do another one. Quietly. Okay, x equals negative b over 2a. Marion, okay, you guys, you need to go watch Super Wide. Now, Elsie, go play with your sisters. Now, come on, Mama's getting mad. No more. All right, sorry, I'm human, right? Okay, so negative b over 2a. That's a 2. So this is the same thing as negative 12 over a negative 4, which is 3. So my vertex is at 3 something. Now to find that something, I have to plug 3 up into here. So negative 2 times 3 squared plus 12 times 3 minus 16. So give me 1 second. 9, negative 18. I got 2. Once you plug it into the calculator, you should get 2. I got the 3 by using the negative b over 2a. That's the line of symmetry. And then 3, 2. Now to find your additional points, we take our general pattern and then we multiply all of the ups. You never multiply the overs. You only multiply the ups by a. So instead of going over 1, up 1, I'm going to go over 1, down 2. Instead of over 2, up 4, I'm going to go over 2, down 8. Your graph looks something like that. Let's keep going. I don't have much time left, and I'm sorry. So let me peek at this really quick. We're almost done. I can do one more of these with you. Let's do number 25. And then discriminant, graph, solve the equation. We did one of those in class. I'll do 28 and then 29, and then we'll be done. So 25, 28, 29, unless those numbers don't line up with yours. All right, 25 is different. It gives it to you in factored form, not standard form. So in factored form, these right here are my x-intercepts. You can find them very quickly. So positive 1, negative 1. Somewhere right in the middle of those is the line of symmetry. The line of symmetry is right here at 0. So to find what y value will give you that line of symmetry, or where the vertex is right here. Sorry, let me back up. To find the y part of the vertex, we know x is 0. We need to find the y part. So everywhere there's an x, you plug in a 0. Sorry, I went upwards instead of going down. So your vertex is right here. Now I do want to put in more than the 3 points. Just because I want my graph to look accurate. So what's the general pattern? Over 1, up 1, over 2, up 4. But in this case, I'm going to multiply all of my ups by 2. Why do I multiply all of my ups by 2? It is because a equals 2. So to find the next point, rather than going over 1, up, over 1, up 2, that worked, like you expected that. I feel like I'm rushing. It's probably because my children are driving me crazy. Oh, I love you. Oh, thank you. No, don't climb on. Okay, from the vertex, you go over 2, up 8. So over 2, up 2, 4, 6, 8. 2, 4, 6, 8. Take it down. And then you graph. Sorry, that doesn't look very pretty, but I kind of don't care. Understanding how this works right here is going to help you next year when you have a cube root or a cubic or a square root or all sorts of other things. Okay, moving on, number 28. says this. If the question simply asks you to factor, you cannot do what I'm about to do. But if it asks you to solve, the very first thing I look for is, does it factor? What?
You want to ask my name?
You can tell them something, but I really want to be done, so you have to hurry. Tell them something.
My name is very cute and it's very funny and he has eating cereal.
Okay, hold on. What was really cute? And really
That's
funny?
funny.
What was funny? Okay, get down. Now go play.
I
Okay. Go away. Guys, I'm almost done. Just go away for 1 minute. Okay, bye.
Bye.
I warned you, I think, at school that this could be bad. I'm going to divide everything by a -3. When I do, the problem becomes easier. So I get x squared plus 5x plus 4 equals 0. Elsie! Elsie! Shh! Elsie! Shh. Okay, for 2 more minutes, okay? Now, if I were factoring it, I would have written like this. And you would have had to keep the -3 out there. But I could divide everything by 3. So 3 divided by 3 is 1. 15 divided by 3 is the 5. 12 divided by 3 is the 4. 0 divided by 3 is 0. It didn't change the value of my x. It just made my my numbers easier to work with. Because now I can play the game, and the game works. P.S. If the game does not work, you have to use the quadratic formula. If the game does not work, you have to use the quadratic formula. Looking for 2 numbers that multiply to 4 and add to 5. Plus 1 plus 4. And if I'm solving this, then either my first one has to be 0, because you're finding the x-intercepts, right? Or my second one has to be equal to 0. One of those 2 things are true, which means x either equals -1 or -4. You would have gotten the same answers had you done the quadratic formula. Okay, one last one, number 29. A swimmer dives into a pool and reemerges 4 seconds later. So, here's the pool. Dives into the pool, comes back up 4 seconds later. The path traveled can be represented by a quadratic equation. At the deepest point in the dive, the swimmer is 6 feet below the surface. Assuming the speed is constant, what is the equation for the swimmer's path? Okay, so we first have to put the axis on. We make, oh, baby's crying. We make these the intercepts. Can you hear that? Hold on. What is wrong? What is wrong? Elsie? Play softer. Okay, stop playing the fair. Okay? I have to hurry and finish. One more problem, okay? Okay, be good. Sorry. I wonder if anybody will even watch this. I don't know, but okay, so we are going to choose these 2 to be intercepts. The first 0 is at 0. The next 0 is at 6, because it's 6 seconds later. Okay, now we need 1 additional point, and then it's the same kind of question as we did a few seconds ago. So the extra point happens here. Don't touch. Don't touch. So that next point happens here. Well, if it takes, oh, is it 4? So sorry. Backing up. This is a 4, because it's 4 seconds later. I misread. It's a 4. So this point right here is the halfway mark. So after 2 seconds, how deep is this diver? There. Get out. Marin, hush, puppy. Okay, Jump on down. Go play for 1 minute. Mary, go give me a toilet paper. Go give me a tissue. Go give me some tissue. Okay, so the point is 2, -6. The 2 because it's in the halfway, the -6 because that's how low the swimmer dived. Now we need to come up with the line that follows this equation. So y equals a times x minus my first 0 times x minus my second 0. Now this is the xy we will be temporarily plugging in. Oh, thank you. Can you go get me more? So everywhere there's a y, we put a -6. A, 2 minus 0, 2 minus 4. Come up here. -6 equals a times 2 times -2. Sorry, I'm racing here. And then let's divide both sides by a -4. When we do that, we get a equals 1.5. Oh, thanks, Marin. I need one more. She's on some like random task to find me toilet paper because that will keep her busy for 2 minutes. I'm so sorry. It's been out of control and crazy. Whew. So finish this off. Y equals 1.5 times x minus 0. You don't have to have that. You could just have x times x minus 4. I love these problems. Thank you. I need a bigger piece, Marin. Okay, I hope that was helpful. 36 minutes later, about 18 of those minutes were yelling at my children, and the other 18 we actually got some good math in. I hope that you got this. I will be there tomorrow morning. Please come in and ask me questions. Because it's critical you do well. We want to end this quarter strong. Thank you. Okay, no more. All right, thank you for watching. Peace out.